Welcome to this recorded lecture of computer programming sessional class, and the topic for discussion in this lecture is repetition control statements. Such statements or program structures are also popularly known as loops. Needless to say, it's a very important topic and should be learned well to code effectively and efficiently. In terms of the syllabus or course content being covered, we are at this stage as indicated by this red rectangle. The first part of control statements dealt with selection statements, if, else, switch case, etc., and was covered in detail in the previous class. In today's lecture, loop or iteration statements such as for, while, do while, etc. are going to be introduced. The contents of this slide should be familiar to you as these were discussed in the introduction to selection structure. If basic programming structure is considered, there are three distinct classes. First one here is the sequential structure. It is a linear structure where execution starts at the top and finishes or ends at the bottom, with all the statements in between being evaluated and executed sequentially and only once. So that is the sequential structure. Second is the selection structure, which has already been discussed in detail in the last lecture. Here, depending on the test question or test condition, to be more precise, depending on the true-false answer to the test or control question, one of the two available branches is executed while the other is skipped. So not all these statements in these sort of programs are executed. As based on the answer to a test question, one branch of code is selected, such structures are also known as selection structures. Such a structure builds into the program a capacity to implement simple decisions, such as whether to follow branch A, that is the true branch, or to follow the false branch, the B branch. Examples of selection structure are if, else, switch case, etc. Now these two programming structures, simple programming structures, have already been discussed in previous classes. Now we come to the repetition structure. Here, based on the answer to the test question or test condition, a block of codes may be executed multiple times. If the answer to the test condition is true, then the sequence of statements is executed and control returns to the test condition again, which is evaluated again. So the block of codes is repeatedly executed till the test condition becomes false. Once that happens, the control or execution exits the loop and continues to the next statement after the loop. Such iterations or loops can be set up using while, for, and do while statements. So I hope this gives you a preliminary idea about loops, and let us now move forward to a more formal definition of loops or iterations. We can say that in programming, a loop is defined as a block of codes that is repeated until a specified termination condition is satisfied. So that is the formal definition of loops. In C programming, there are three types of looping structures: while loop, for loop, and the do while. We will discuss these repetition structures or iterative statements one by one, starting with the while. While is the most fundamental and simplest form of iteration or repetition structure provided by C. It repeatedly executes a block of statements as long as a given test condition evaluates to true. Let us now try to understand the while loop structure using a flow diagram. First of all, the execution or control encounters a test condition or expression. This test condition or expression could be a simple relational expression or a compound one, that is connected together by the use of logical operators. It could be logical AND, or it could be a logical OR. To give you an example, I less than equal to 5 is a simple relational expression. J greater than equal to say 10 is also a simple expression. But this one is a compound one because we are using the logical AND operator to combine together two relational expressions. So the first two are examples of simple relational expressions. The last one is the example of a compound expression. So a parameter or index is being checked against a constant or other parameter values. And the expression when evaluated gives as answer true or false. Now in C, true is equated to a value, integer value of 1, whereas false is equivalent to an integer value of 0. If the test expression is true, then execution enters the loop, the while loop. And the statements, that is all the statements within the loop, are executed. Once all the statements are executed, then it goes back to the test condition and evaluates it again. The process is repeated if true is obtained as an answer. So you can see how a loop is set up here like this. So it follows this loop. How long does this continue? It continues till a false answer is obtained. That means the process goes on until the test expression evaluates to false. Once that happens, the loop is terminated and the control exits from the loop to go to the next statement right after the while loop. It goes right here. So that is the logical explanation of how a while loop operates. Let's see now how it can be written in C syntactically. So here is the syntax of the while loop. As you can see, the keyword while is followed by the test expression or test condition within the parenthesis. After that comes the curly braces, and any statement within the curly braces constitutes the body of the while loop. Now there could be multiple statements here or even a single statement. Now it is quite clear to see here that the test expression is situated right before the body of the while loop. So the condition of the loop, the test condition, is tested or evaluated before the body of the loop is executed. Hence, it is an example of an entry control loop. Later on, we'll see an example of an exit control loop. However, now let us look at a very simple example of a block of C code that implements the while loop. Here, you can see at the beginning that I is initialized to a value of 0. Then, following the keyword while, the test expression checks whether this index I is less than or equal to 5. Obviously, as I has a value of 0, this test condition evaluates to true. So the execution would enter the while loop. Within the body of the while loop, there is a printf statement that prints the value of I. So I equal to 0 would be printed here because, as you know, the value of I at this stage is 0. But after the printf statement, the value of I is incremented using a very simple assignment, I equal to I plus 1. So now the value of I becomes 1. After this is done, all the statements within the body of the while loop are executed. So the control returns to the test condition and it is being tested again. By the way, now the value of I is 1. But still it gives a true answer because 1 is less than 5. So again that will enter into the body of the loop, execute the printf statement again with the output being I equal to 1. And at this stage, I would be incremented to 2. So this iteration, this loop would continue as long as I remains less than equal to 5. But there will come a stage when I becomes 6 in the natural course of action because at every iteration, I is being incremented by 1. So when I becomes equal to 6, then the test condition is not true anymore. So that is where the loop will be terminated and the execution would move past the while loop to the statement just after the loop. So that is how this loop is going to be executed. Now the question is how many times the loop would run. So we start with I equal to 0 and we go up to I equal to 5. When I becomes equal to 6, the condition is false. So that does not enter the loop. So starting with 0, ending with 5, we have 6 iterations of this loop. And what would be the answer? Do notice that there is a new line statement within the printf. So the I values would be printed one after the other like this. So that is the output of this loop. Here, I would draw your attention to 3 critical aspects of this loop. First of all, there is an initialization statement. Then there is the test expression. And finally, there is the update statement. Now, if one of these 3 things are missing, then obviously the loop does not run as expected. Suppose the update statement has been deleted from here. Somehow somebody has forgotten to give the update statement. So what will happen is that I will continuously remain as 0. There is no change in the value of I, and whenever it goes back to the test expression, it evaluates to true. So this will set up a very critical error which is known as an infinite loop. Another example of an erroneous loop would be if this, instead of this increment, a decrement is provided. So I becomes equal to I minus 1. So in each of the iterations of the loop, the value of I would be decremented. So at first, if it is 0, then it becomes minus 1, then minus 2, and so on. So would this test expression ever become a false one? It would never become false because it goes in the opposite direction to 5, positive 5. It will move in, value of I would move in the negative direction. And whenever the condition is tested, it will give back a true answer. Again, an infinite loop will be set up. So it is extremely important and critical to provide all the statements, initialization statement, the test expression, and update statement very carefully with considerable thought. It must be kept in mind that the test expression eventually must evaluate to a false answer. So this is an example of a while loop. By the way, one more thing is that the initialization statement I equal to 0, it need not be right before the while loop. It could be anywhere before the while statement. but it is also important to initialize to a particular value so that you have an idea, depending on the test expression and the update statement, how many times the loop is going to run. So here is an improved flow diagram of the while loop, where the initialization statement along with the update statement within the body of the while loop has been incorporated. The corresponding syntax can be written as like this. So again, the initialization statement is mentioned or provided before the while loop starts, and there is an update statement within the body of the while loop. Now it must be mentioned here that this update statement can be provided anywhere within the body of the while loop. So if we consider the example that was discussed in the previous slide, then instead of providing it after the printf statement, it could have been provided before, and that would have worked okay. There would be no problem with this loop. However, if you do not provide the update statement, then obviously it leads to an error. But as I stated just now, this update statement can be provided anywhere within the body of the while loop. So let's take this example of the update statement being provided before the printf statement. So initially the value of I is 0. The test condition is true. It enters into the loop and updates the value of I to 1. Then there is the printf statement, and it would print the output as I equal to 1. Then it goes back to the test condition again, which is true again. So the while loop is entered, and there is the next updation of the value of I, and it becomes 2. The printf would give us I equal to 2. So like that, it is going to continue. It will continue till I equal to 6 is obtained. So at this final stage, when the test condition is checked, I is equal to 5. Once it enters into the loop, its value goes to 6. That value is printed, and then it goes to check the condition again. Now as I is equal to 6, the test condition is not satisfied and it will exit the loop. So again, to reiterate, the update statement can be provided anywhere within the body of the while loop, but of course there may be changes in the output of the program depending on where this statement is provided. Now that we have discussed the while loop in quite a bit of detail, let us move on to the next iterative structure, which is the for loop. If you have understood the logical operations or logical structure of the while loop, it would be quite a bit simpler to understand the working of the for loop, because it follows the same logical structure. A for loop is a repetition control structure that allows to efficiently create a loop that needs to execute a specific number of times. That is, the number of iterations are fixed. As already mentioned, a for loop has a similar logical structure to the while loop as discussed before. Let us now try to explain that with the help of a flow diagram. First of all, there is the initialization statement. Here, the initialization statement is made part of the syntax of the for loop, and this statement is executed only once. After that, the control moves to a test condition or test expression, and this test expression is evaluated to answer true or false. If the test condition gives a true answer, if it is evaluated to true, then the statements inside the body of the for loop are executed. Once all the statements are executed, then we have an update statement where this update expression is evaluated and it goes back to the test condition again to be evaluated again. Now this condition checking is done with respect to the updated value. If the answer is true, then obviously it follows the true branch and the loop is set up like this. Once the test condition evaluates to false, then the loop is terminated and execution moves to the next statement after the for loop. So this is the entire loop which is set up, and it also contains an initialization statement, a test condition, and an update statement. Obviously, there would be multiple statements inside the body of the for loop as well. So how do we represent this for loop as shown in the graphics here in C language? So here is the syntax of the for loop. Obviously, it starts with the keyword for here, and it is followed by 3 consecutive statements inside the parenthesis. Here the initialization statement, the test expression, and the update statement are all provided together at the beginning of the loop. Obviously, it doesn't mean that they are all evaluated at the beginning. First of all, there is the initialization statement, as you can see in this graphical diagram, that is evaluated, and it is evaluated once. Then comes the test expression. If this test expression is true, it goes inside the body of the for loop and executes these statements. And only when all the statements are executed, then it evaluates the update statement. So although they are mentioned in one line at the beginning of the for loop, they may be evaluated at different times. Now do note that these expressions, these 3 expressions, let's say E1, E2 and E3, are separated by semicolon. It's a very common mistake to replace these semicolons with comma, and if you do that, you will get an error from the compiler. So as mentioned, this is the syntax of the for loop. First of all, mention the initialization statement, then after the semicolon provide the test expression, and then after providing another semicolon give the update statement. The body of the for loop is obviously contained within the curly braces. Let's have a look at an example here. So here we have the keyword for, then the parenthesis. Within the parenthesis, you have the initialization statement I equal to 0. After the semicolon, this is the test expression I less than equal to 5. And finally, there is the updation statement, which is an increment of y. So I++ is provided here. Within the body of the for loop, there is a single statement, single printf statement that prints the value of I. So this program basically does the same thing as the while loop example that was provided before. So at the top of the loop, there would be the initialization. First of all, I would be equated to or assigned a value of 0, and that would be checked against this value of 5. If it is true, it goes inside the loop, prints the value of I as I equal to 0, and then it will evaluate the update statement. As it is given as I++, it will become 1 and go back to the test expression. It will not go back here. The initialization statement is evaluated only once at the start of the loop. So when it comes back for the second iteration, this is not evaluated. It goes to the test expression with a value of 1. As that is also true, it will go inside the for loop and again print the value I equal to 1. After that, there is increment of I, so it becomes 2 and it goes to the test expression again. If you are confused about that particular part of how this loop works, just remember this flow diagram. As you can see, as the loop is set up, once the update statement is executed, it goes back to the test condition, not the initialization statement. So this is the loop. So what would be output of this particular loop? This loop also runs 6 times because it is equivalent to the while loop that was discussed before, and it gives an identical output also. Now we can have different types of test expressions and update statements, and this second example gives us a view into what else can be done in the for statement. So here the value of I is initialized to 5. A test condition that is being checked is I greater than equal to 2. And the update statement here is in fact a decrement statement that continuously brings down the value of I. Within the body of the for loop, there is the same printf statement that prints the value of I as I equal to the integer value. So here the loop starts with 5. So at the first iteration, when it goes inside the loop, obviously 5 is greater than 2, so it evaluates to true. So the execution enters into the loop and it will print I equal to 5. After that, there is a decrement of I, so the value goes down to 4 and it goes back to the test expression again. If that is evaluated, it gives us true again, and the second iteration of the loop would run. Here the output from the printf statement would be I equal to 4. Like that it will continue till the test expression becomes false. That means I becomes equal to 1. And that would happen quite naturally because at each iteration we are taking down the value of I by 1. So how many times this loop would run? This is going to run 4 times. And the output would be like this. So it goes up to I equal to 2. And after that, the value becomes I equal to 1. And that does not satisfy the test expression. Hence, the loop would be terminated. So this is how the for loop works. And again, I would reiterate that you need to be very careful about the update statement as well as the test expression. Because if you set up the for loop in a wrong manner, suppose here you have provided a greater than equal to test condition, but you are incrementing I from a value which is greater than the constant in the test expression. Suppose I have mistakenly provided, instead of I minus minus, I plus plus here. So what would be the problem? This test expression would never evaluate to false because value of I here is 5. So it moves up from 5 in each iteration and it would never go below 2. So it never evaluates to false and you have the problem of an infinite loop. So infinite loops must be avoided at all costs. And for that to happen, you need to be very careful about the initialization statement, the update statement, as well as the test expression. In this slide, the equivalence between the for and the while loop is discussed. The flow diagrams and the syntax corresponding to these two loops are provided here. One can see that the initialization statement, the test condition, and the update statement make an appearance in both of them. So here is the initialization statement, here is the test condition, and there is the update statement. However, there is subtle differences in execution of these loops. In for loop, the update statement is executed at the end of the body of the loop. That is, once all the statements are evaluated, only then the loop index is updated. By the way, loop index here refers to the variable that controls the loop. So if you think about the previous examples, I would be the loop index. On the other hand, in while loops, update statements can be anywhere within the body. It can be at the start or the middle or at the end of the body of the loop. So it could be anywhere within the body of the loop. In case of for loops, the expressions controlling the execution of the loop are grouped together and provided at the top of the loop here. So all this information regarding the initialization statement, the test expression, as well as the update statement are available at a glance right at the top of the loop. It offers better clarity. For while loops, the initialization statement may be before the while statement anywhere in this program, whereas the update statement may be buried within the body of the loop having a lot of statements. So all the information may not be available at a glance and may be difficult to find out. So in situations where clarity dictates that both the control and the indexing be kept visible at the top of the loop, the for statement is the natural choice. But one should also remember that the logical structure of these two loops are very much similar. So either can be employed to obtain the same outcome. So finally, if we ask the question that which one is the preferred iterative structure, the while loop or the for loop, the answer quite simply is that it depends on the personal preference and choice of the programmer. Whichever structure, iterative structure, he feels comfortable with, he can employ to obtain the results. I think we have discussed the for and the while loop in quite a bit of detail. Let us move forward now. Let us now talk about the third iterative structure, which is known as the do-while loop. This loop or iterative structure is similar to while loop with a major and critical difference. Here, the test condition appears at the bottom of the loop, that is after the body of the loop. So, the statements within the loop need to be executed first, and then only the test expression is encountered and evaluated. As the condition is checked after the body of the loop is executed, it is known as an exit control loop. Let us now have a look at the flow diagram of the do-while loop and see its critical difference with the previously discussed while loop. So here one can see that the body of the do while loop comes first, and it needs to be executed first, and then only it can go to the test condition. Once the test condition is evaluated, the answer again can only be true or false. And if the answer is true, then the body of the loop is executed again and the test expression is evaluated again. So that is how the loop is set up here. And this continues till the test expression becomes false. As it becomes false, then the loop is terminated and control exits from the do while loop to go to the statement just below the do while loop. So this is the structure of the do while loop. The critical thing to remember from here is that the do while loop is executed at least once. So here is the syntax of the do while loop. At first comes the do statement. Within the curly braces after the do statement is the body of the do while loop. So all the statements within these curly braces make up the body of the loop. After the body of the loop is over, you have the while statement followed by the test expression within the parenthesis. So you can pretty easily understand that as control or execution comes from the top, all the statements within the body of the do while loop is executed first, and then only this while statement is encountered and evaluated. So whatever happens at this test expression, before that the body of the do while loop has already been evaluated once. So even at this first checking of condition, if the value turns out to be false and it goes out of the loop to the next statement, you have already one iteration or one execution of the body of this loop. Now let us have an example of the do while loop. At first here, I is assigned a value of 0 as the initialization statement. Then you have the body of the do while loop. Within the braces, you have the printf statement and the increment command or the update statement. After the body of the loop is over, then you have the while statement and the condition check. At the first instant, when the value of I is 0, it directly comes to the printf statement, outputs I equal to 0, then goes to the increment statement, increases the value of I from 0 to 1, and then checks the condition. At this stage, 1 is obviously less than 5, so the test expression gives a true answer. Obviously, it will then go back to the top of the body of the do while loop and execute the statements within the loop again. Now, the printf would output a value of I equal to 1. Then the update statement would increase the value of I to 2 and the condition would be checked again. Needless to say, this is again evaluated to true as 2 is less than 5 and the loop would be repeated again. So what we obtain here as output is something like this. So it starts with I equal to 0, goes up to I equal to 5. Now what happens once the value of I has gone to 5? Obviously you have printf I equal to 5 is given as the output here, that is shown here, and then this value of I is incremented again by 1 and it becomes 6. Now when we come to the test expression, 6 is not less than or equal to 5. So that evaluates to false. As it evaluates to false, it moves to the next expression or next statement after the do-while loop. We can consider another example here where the value of I, that is the assignment, is given as I equal to 6 at the beginning itself. When it comes to this printf statement, it will print. So from printf, the output would be I equal to. After that, it would be incremented, and that would make the value of I as 7. When it comes to the test expression, 7 is obviously not less than or equal to 5. So this gives a false answer. So it becomes false and it moves out of the loop. So at the first condition checking, we have the false answer. But still, the body of the loop has already been evaluated and executed once because it is before the test expression. So that is how a do-while loop works, and that is why it is said that the body of the do-while statement is executed at least once, whatever be the test condition. In this lecture, we have discussed the repetition or iterative structure and introduced while, do-while, and for loops. These programming structures provide for repetitive or iterative execution of a block of codes. Here the syntax of these loops are presented. And as a summary to the lecture that we have just now had, certain points would be highlighted. First of all, for and while loops have the same logical structure and can be used to the same effect, that is, obtain the same outcome. Second, for statements offer better clarity as all the information regarding control and index of the loop are available at a glance at the top of the loop. Third, the while and the for loop are entry control loops, whereas the do while loop is an exit control loop. As a result, the body of the do while loop would be executed at least once. Finally, the critical error of infinite loops must be avoided at all costs. It usually happens due to the mishandling or miscoding of the control expressions of the loop. Control expressions or controlling expressions being the initialization statement, the test condition, and the update statement. In order to avoid the error of infinite loop, it must be ensured that the test condition eventually returns a false answer. That brings us to the end of this lecture.